In this session, we'll solve some numericals on the alternator, that is, how to calculate the generated voltage from the terminal voltage, taking into account the different drops in the alternator. The first numerical, that is, it is a 50 kVA star connected 440 volt 3 phase 50 Hz alternator, and its effective armature resistance is 0.25 ohm per phase, whereas its synchronous reactance is 3.2 ohm and the leakage reactance is 0.5 ohm per phase. He asks you to calculate at unity power factor what is the internal voltage, that is EA, then the no load actual generated voltage E naught, then the percentage voltage regulation on full load, and the value of synchronous reactance which replaces armature reaction. That is, we have to find out these quantity. First, from the given data, all the calculations are made per phase basis. Therefore, we have to convert the line voltage, that is 440 volt, into the phase voltage, and you have to calculate the line current. Then in the case of star connection, the line current is the phase current. Then we will proceed for the what he asked. That is, the first I am taking, that is I am taking V, that is a terminal voltage, that is per phase voltage, that is represented by Vp. That is, in the case of star connection, the per phase voltage is PL by root 3, line voltage divided by root 3, therefore it is 254 volts. Then the voltage is taken as a reference, therefore I am writing P as 254 and angle of 0 degree, that is taken as a reference value. Then I have to calculate the armature current I, that to per phase value, therefore I am representing this as IP is equal to IL, because it is star connected. IP is equal to IL, that is nothing but our armature current, that is given by kVA into 10 raised to 3 divided by root 3 into PL. Then you have to substitute the value of kVA and VL in this equation. What you are getting is 65.6 amperes is the full load current. Therefore, your IA is 65.6 and angle of 0 degree I am representing, because he asked you to calculate determine the regulation as well as no load voltage and the internal voltage at point unity power factor. Therefore, the angle phi is 0, because cos phi is 1, therefore phi is 0 degree. Therefore, these are the voltage and the current. Then the first thing what he asked is the internal voltage EMEA. Internal voltage EA, it is nothing but it is the internal voltage that is excluding armature reaction. It is excluding armature reaction. Means it is a terminal voltage V plus IARA drop plus IAXL. That is, here we are excluding armature reaction. That gives the internal voltage. If you are including leakage reactance and the armature reactance, then what we are getting is the internal voltage. Therefore, the EA is V an angle of 0 degree plus IA an angle of phi. It is RA plus XL into I, that is leakage reactance. Here the power factor is unity, therefore phi you have to take it as 0. Therefore, I am substituting the value for V is 254 an angle of 0 degree. Similarly, I is 65 an angle of 0 degree, and the resistance is 0.25 and leakage reactance is 0.5 I. Therefore, if we are calculating using a calculator, then what we are getting is 272 volts. I am not interested in the angle, therefore you can find out what is the value of EA, that is the magnitude, that is the internal voltage excluding armature reaction, that is called as internal EMF, that is what we are getting is 272. Then The part B is what is asked is no load EMF E naught. Here you have to consider synchronous reactance Xs. Therefore, your EA should be, that is E naught. It is a E naught, or you can call EA, or sorry, it is E naught. This value is E naught. That is E naught is equal to B an angle of 0 degree, IA an angle of phi, RA plus XS. I am taking here it is XL for internal voltage. For the no load voltage it is XS. That is what we are calling is no load EMF, it is XS. Therefore, you have to substitute value of V and I, and this is 0.25. Here's synchronous reactance is 3.2. Then after substituting, then what we are getting is E naught is equal to 342 volt is the internal voltage. That is, you are getting the internal voltage here, it is the no load voltage. Then the third part what is asked is the percentage relation, which is nothing but E minus V divided by V into 100. That is what I am putting here is percentage relation is E naught minus V divided by V into 100. Therefore, if I am substituting, the value of E naught is 342 minus 254 divided by 254. All thing is multiplied by 100. Therefore, what we are getting is 34.64% is the percentage voltage regulation what you are getting. Then the D part is asking you to find out the XA, but we know that XS is equal to XL plus XA. Therefore, XA is equal to XS minus XL. Therefore, XA what I am getting is 3.2 minus 0.5, that is XA is 2.74. This is how we have to find out the value of the XA. The next numerical is a 100 kVA 3300 volt 3-phase star connected alternator. It is delivering the full load current at rated voltage of 0.8 power factor lagging. First it is delivering the 0.8 power factor lagging. The resistance and synchronous reactance is given as 0.5 and 5 ohm respectively. Estimate the terminal voltage for the same excitation, the same load current at 0.8 power factor leading. That is, in the second case, what he is changing is changing from 0.8 lag to 0.8 leading power factor load he is connecting. In that case, what should be the value of the terminal voltage V, so that the generated voltage remains same because he is keeping excitation constant. Means what you have to do is you have to find out what is the excitation voltage first at 0.8 power factor lag. That internal voltage, or you can call the no load voltage, is keeping constant, so that excitation is constant. In that case, you have to go by reverse engineering, that you have to find out from E, you have to find out V for 0.8 power factor leading. First I will take it up for the lagging power factor. What is the internal voltage? That is a generated voltage. First, once again you have to go for V, that is per phase voltage you have to calculate, that is 3300 divided by root 3, because it is star connected once again. That is what we are getting is 1905 volts is the terminal voltage. Then IA is equal to IP is equal to IL. Once again you are getting kVA into 10 raised to 3 divided by root 3 into VL. Thereby what we are getting is the IA, that is the armature full load current, is 175 amperes. Then cos phi is given as a 0.8 in the both the case. Therefore phi in the both the case is 36.86. In the first case it is a lagging, that is minus 36.86. In the second case it is a plus 36.86, that is leading. First you have to draw the vector diagram for lagging power factor. This is your V. Then you have to add IRA, that is I is lagging, V by an angle of phi. Add IRA, then IAXS, then what we are getting is E. This is angle delta what we are getting. Here Our intention is to find out the value of E. Therefore, the E is equal to V an angle of 0 degree plus I an angle of minus 5 because it is a lagging power factor and RA plus XS into I. Just have to substitute the value, that is 1905 an angle of 0, 175 is the current, an angle of 36.6, it is a lagging power factor, then 0.5 plus 5I. Then if you are work out this, what you are getting is 252,582 an angle of 14.52 as a volt. This is, I am not interested in the load angle delta, but is what I am interested is excitation voltage. This excitation voltage remains constant, then I am connecting the leading power factor load, then what should be this terminal voltage V? That is, if the load is changing from lagging to leading, keeping the excitation voltage constant, what should be the terminal voltage for leading power factor load of 0.8? That is our intention. Therefore, the generated voltage E 2582 you are keeping the constant. Then we have to find out the value of V now. Then our voltage will fall on this particular reference axis because we are taking V an angle of 0 degree, which is along this reference axis. But I don't know what is the value of the V. But definitely the vector of the V will fall on this particular reference axis. Then you can draw the current which is leading, I know that is 175 and it is leading. Suppose the voltage is lying on this, then it is leading means we are getting here in the upper portion, that is in the anti-clockwise direction, an angle of 36.86. If this is the current IA here, if you are getting, that is, just I will show you. The voltage will fall on this, but I don't know what is the value. Then the current has to lead this by an angle of the phi. This an angle of phi. Okay, here we are having the voltage V. This is voltage V. I don't know what is the value, but I know that IA should be making an angle of phi with this. With that background, just I want to show you. I am starting drawing a current IA, I told you, which is making leading an angle of 36.86 with this respect to reference. Suppose this is I, then first I have got IRA because I know the value of IA, I know the value of RA, then I know the value of IARA, that is the resistive drop. The resistive drop is parallel to IA. I am taking any arbitrary point on this because it will start, that is IA is, V is falling in this. Somewhere it is ending. I call some point on this. Suppose at this the V is ending. Then I don't know what is the magnitude. I have to find out that. But definitely the tip of V I am calling this as the tip of the V. To tip of the V, what I have to add? That is IARA. First I am adding IARA here because it is IARA making it is parallel to I. To this IARA, I have to add IAXS, which is perpendicular to IARA or perpendicular to I. Then, from here, you have to draw a vector that is equal to E, that is equal to 2582. That is 2582, so that the tip of that 2582 should fall on this. Because that is the voltage we are getting, it is the starting point. Therefore, you have to take 2582 as R and you have to cut here so that it will touch somewhere here. That is, this vector we know that is 252. Therefore, you draw a vector 252 so that the tip is touching this reference axis. This total distance is 252. Then ultimately, this value what I am getting is the value V. But it is a graphical method, but what I am interested is, and I want numerically what is the value of V. This is a pressure, that is Vector IA, we know that is making an angle of 36 point with respect to reference. Then accordingly I am adding IRA, I know the value of IXS, I know this vector, and also I know the value of E. Therefore, all these if you are adding, then the remaining portion, that is a gap, what we are getting is the value, the V. Then for that, how to find out that? This angle is phi, this angle is delta. Some of the construction line I am making, it is AB is a V, then I am drawing GH and KG, that is from the tip of IRA and tip of that is I axis. This is a construction line. Then I know the values of IRA, IXS and phi as well as E. That is, these are the known quantities because I know the value of IA, I know the value of RA, finding out IRA, IA value known, XS value known, I am finding out it, that is IXS. Phi is also known, E is 2582.5 volts is that you already, this is keeping constant. Therefore, now I am interested in AB, that is the value V. That is, my objective is to find out the value V, that is nothing but it is AB. Therefore, AB I am writing in terms of AJ minus BJ. That is, this is AJ minus BJ, that gives the value of B. Because I don't know the value of AB, but I know the value of AJ, I know the value of BJ, then I can express AB in terms of AJ and BJ. Therefore, what I am doing, that is, it is AJ minus BJ, so that we are getting AB. Therefore, AB is equal to AJ. So to find out AJ, AJ is nothing but it is AH plus HJ. That is, AJ is also can be expressed as AH plus HJ. Okay, this is just like it is a mathematics. It is AH plus HJ, that gives the AJ. I am keeping BJ as it is. Therefore, AB is nothing but V, AB is nothing but B, AH, you can see the AH. What is that AH? This is A to H. You take a triangle AGH, AGH, AGH. In AGH, hypotenuse is E, adjacent side is AH, therefore AH is equal to E cos delta. This is angle delta. That is, you have to take the triangle AGH. From AGH, what you are getting is E cos delta. Then, at the same time, HJ. HJ is equal to MN. MN is equal to GK. Whereas this angle is phi. This hypotenuse XS. GK is opposite side. Therefore, it is IAXS sin phi. Then BJ. That is, what is that BJ? BJ is this. BJ is this. To take a triangle of B and J, so that what we are getting is it is IARA cos phi. Therefore, the known quantities are E is known, delta you have to find out, IXS sin phi everything is known. Means my main objective is to find out the delta. Therefore, once again from the triangle you can see here GH, that is GH is equal to GM plus MH. Therefore, GM is nothing but KN, whereas MH is nothing but NJ. Therefore, from the triangle NGK and NHJ, we can find out the values, so that we can find out the GH. From the GH, what we are getting here is the value of the delta. That is, GH is equal to E sin delta. Therefore, the delta what we are getting here is 16.94. If you know the value of the delta, then you can substitute here. Then what we are getting, V is equal to 2925.44. That is, just you have to make it AGH. The AGH, GH is nothing but opposite side. That is what we are getting from here. That is, GH is equal to E sin delta. Here from this, then the GH is also you are getting from the